Swayam Prabha. Digital India. Educated India.
Speech and hearing impaired face a lot of challenges in their daily lives. Although some work has been done to help, but a lot still remains to be done. Today, we are going to meet a team of SIH winners that provide a solution to ensure equal access to education, healthcare, and services where sign language interpretation may not be available. They have created AI tools for Indian Sign Language generation from audio-visual content. Let's get to know more about it from the team itself. So, welcome Mukund and Suraj.
Thank you, sir. Hello, sir.
Hi. So, to begin with, let's know something about you first of all, and then we can carry on with the work that you've done. So, tell us something about both of you.
Okay, sir. So I am Mukund Kushwaha. Originally, I am from Lucknow, Uttar Pradesh, and currently I am studying aerospace engineering here at IIT Bombay.
I am Suraj Prasad. I am also from IIT Bombay doing mechanical engineering, and currently I'm in third year. I'm very passionate in building and training AI models on very large data sets. That's my passion.
So both of us carry a passion for creating solutions for problems that emerge in the society, specifically to India.
Obviously, wonderful. And first of all, congratulations to both of you for winning the SIH 2024. Now is the time to talk about that winning idea. So the problem that you were working on was something which hasn't been worked like a lot upon. That has been overlooked by many in the past. But you have created, tried to solve an issue which is like long pending. So to begin with, please tell us something about the problem that you saw when you started to work on this particular solution.
Okay, so the problem that we are solving is for the hearing impaired people and the people who cannot listen properly. They use sign language for this, and the people who don't understand sign language cannot really speak to them. Only the communication medium is through text over WhatsApp, or they can show the screen, but that is a very slow method of communication. We also have a very personal connect with the problem, which Suraj will explain.
I have personally experienced this problem. Like, my big brother is both speech and hear impaired, so he found like very difficulty in general in going to school, learning from the teachers, finds very difficult in job market itself. So job market for hear and speech impaired persons are very less, and even like if you go on railway platforms or airports, the announcements that happens over there, there is no way that they can hear those announcements, like can benefit from those things. So that was the trigger point, from myself within, ki this hackathon, such a large hackathon, can we come up with some innovation or some tools that can really impact the deaf community or the hearing community in general. So that was the trigger point to solving in this problem, and like we, our team took it as a challenge. Okay, 2 weeks are there, 2 weeks are left. Can we really pull all nighters and come up with some really uh, good solutions that can be deployed, in fact, not only to win this competition, but also to deploy in a marketplace itself, like railways or colleges or schools. So that was the motivation or the trigger point that we had before building this. Yeah.
So that was really a wonderful thought. Coming from a personal space as well as putting it across to all the other people in the society who face this problem of speech and hearing impairment. So tell us, how did this all work out in the sense that not much of work has happened in the past in this particular area. So were there any problems that you faced? Were there any kind of restrictions that you came across while working on this? Were there any challenges?
Yeah, so we faced a lot of challenges. We tried to figure out what previous work has been done, and the same that you said, much work wasn't done already. The challenges included the technology itself, And the second part was the initiative. The Smart India Hackathon facilitated the later part, and the technology was the right time that we entered. And other challenges are also there. Suresh, would you like to
Yeah,
speak?
so as Mukund told, we first looked into the internet. If really, we really dig deep into, is there any previous work that has been done? And like with God grace, like there is a person Amit Morsav, he has done some amazing work on the sign to speech translation and the vice versa. So we had the meet with him in himself and then talked with himself how he come up with what were the challenges he faced and can we build it for the Indian peoples also. So like that meet, that talk went around like 1.5 hours. Then by looking at the research papers and all those things, then we come up with the solutions. So how it went, the real problem was sign to speech translations, and the other part that, so we basically thought from the first principle in the marketplace what is needed the most at this right moment. So we look from the perspective of railways, airports, and all those, and major public announcements places. There we looked key if a product which can translate our voice, like normal people voice, to sign language, that is the crucial part that we need to solve at this right moment. So we focused on building this first pipeline, like speech to sign language.
Because then we could target the whole mass market. All the announcement on airports, railways, in fact, the education in schools, colleges, and in fact, the peer-to-peer communication would start when the normal, natural speaking people can talk to the hearing impaired people. And this was our core problem statement. If we can solve this, we'll solve 90 or 80% of the problem itself. The rest would be the other way down, which is from the hearing impaired people sign language to a natural language speech.
So indeed, there is a big gap that was there in this particular area, and you guys picked up the right, problem from there. So now let us know more about what exactly the solution was. What exactly did you, come up with?
So yes, going into the technical details a little bit, there were ISL dictionaries available on the YouTube. So like for each of the words, the government has already provided the video. Like for hello, there is a particular sign. For a train, there is a particular sign like this. So for around like more than 4,000 plus words, already a dictionary has been curated. So what we picked out, let's focus on the train itself first part. So let's try to take an approach of lean type of building. So building from a small scale, and then we will scale it a little bit. So we first, from out of those dictionaries, we took out those words which is being frequently used in the railway platforms or in public announcement in general, around the railways. And from there we created a mapping, a dictionary mapping, which links all the words to the videos. The major challenge here was कि suppose there is a word, a long sentence, and the video for each of the words is around 4 seconds. So if a sentence contains 10 words, the video stretch will go around 10 into 4, like 40 seconds.
Which is very slow.
Which is very, very slow, which is very inefficient. That was the first challenge that we got. So to tackle this, we thought, what can we do better than this? So the main challenge here was like the human itself, the dictionary itself is a problem, because for each of the words, the dictionary itself took 4 seconds to explain. So can we reduce this? That was our initial thought. So we started building on top of this. What we did, we took all the words, we took all the corresponding videos, we passed these corresponding videos to a Python scripts, which basically extract the poses using the media pipeline, which is a sort of library from the Google. So we extracted the corresponding poses, the 3D landmarks. So what happens? In our face, when I'm speaking, like when I'm showing my hands movement, hand gestures, there is landmarks like nose, eyes, ears, and my finger joints, like all the joints over there. So media pipelines extracts all those key points and give you a pose. You can understand pose as a frame of a continuous video. So what we did for each of the word, we extracted those poses, and then from these poses, we mapped all the videos. We mapped all the videos with these poses, and then we run another Python script which we actually custom built it, like lot of iterations we did, and then we seamlessly integrated those each of the words. So what happens? Prior, it was a human who was explaining. Now it is a 3D model. It's not actually a 3D model, but a 2D avatar of a 3D model, you can say, which is quite robust. And we reduced that 40 seconds to just 10 seconds, which is quite good enough for 10 words. So this is how we build it.
So essentially, the computer learned the joint movements, and the facial expression movements for particular words, and then we seamlessly integrated all the words so that the sentence can be formed. And this was quite natural to the hearing impaired people when he showed it to them.
Yeah, and in the hackathon itself, like when we presented this solution to the judges, they gave us feedback. Ki actually in the sign language, people use their facial expressions a lot, and that was a key point that we noted, and that's very true. When a hearing impaired person speaks, or they use the facial expressions for sign language a lot. So we kept that in mind, and in that 36 hours hackathon, we and our team put it a lot of effort in perfectioning the facial expressions in the avatar itself. So, and we did this. We successfully able to did that also. So this is how all these things went.
That was a big challenge.
Yeah, that was a big challenge, and finally, thanks to our team, wonderful team we have. We pull all 36 hours once at a time, and we come up with this solution.
It was an amazing experience.
Yeah.
Core challenges included the data itself. In fact, the previous work that has been done in the field was mostly on American Sign Languages. And essentially, that language is mostly dominated by one signs, and Indian Sign Language is two sign languages. In fact, in India, there is a variety of sign languages that is used. So, Indian Standard Sign Languages, which we term as ISL, is what the government asked us to do. And so, we have to really do the things from scratch.
Yeah, of course.
Yeah.
And as you just mentioned, even while during the hackathon, you kept on improving, you kept on improvising, you kept on, pivoting to come up with a good and better product. So at this stage, what stage are you at? I mean, is there still any more scope left for any more improvements, or anything more that you would like to do in terms of R&D or adding features or something like that?
So yes, we are like 6 people team. So we took a lot of feedback from the judges. We asked multiple questions from them. The first feedback that they gave us, improve on the facial expression, which we did. The second one that they had given to us was as Mukund told, different regions of India speaks different languages. So we integrated that also. That was one part of our team was working on integrating all the Indian languages, Gujarati, Tamil, Bengali, all the languages in the India. So any normal people who speak any language, even the vulnerable languages, we can translate that into Indian sign languages. Now coming to your question, how much is it ready? It's so we are very proud. We are very proud to announce actually we talked with the judges also, we showed them, and we're very confident and we're very proud. Actually, it can be right now integrated into the railway platforms for their announcements. Absolutely, it can be deployed directly to the railway.
Deployable to specific domains.
Yeah.
Yes, it is possible.
It is possible.
In fact, what we have made is at least the best that has been made in the past previous years. So it is the best. We definitely could take it a step further, but for specific domains, yes, it is ready to be deployed. You just have to scale it and make the infrastructure in the railways and airports, for which we need funding from the government and help from the government essentially. But yeah, it is deployable right now.
Deployable. That's wonderful. That's great to know. So to take it a little further, Can you please explain a use case scenario? For example, if I am a person who is supposed to use this, who needs this particular facility, so how does it help me? Like, how do I go about doing it?
So we kept this point also in our mind. So in those 36 hours, we iterated, as like previously, we iterated on multiple things, like a lot of multiple things, only because our team was fantastic. So how it is useful to the normal users, and how it can help the hearing impaired persons. What we focus key, what actually the daily use case which is going on. We saw key Google Meet or the Microsoft Teams. Like many people joins over there. Like many of us have joined Google Meet. What happens when a person speaks? He like directly comes at the front of the screen. So why does this happen? Because they can speak, and the internal backend can recognize your speech and move your screen forward.
But what would happen to the person who is not speaking,
Yeah.
but he is using the sign language?
Yeah. So we kept it into our mind. So we thought, okay, like when a big meeting is going on, like in which like many people have joined, like maybe hundreds and 200 people have joined. There are also hearing impaired persons also. How those hearing people can come at the front of the screen? Can we do something over there? So we built two pipelines, fundamentally two products, sub-products. The first one is when a hearing person is like doing any sign languages, if the sign language is recognizable, meaning if it's a valid sign languages, not just any random hand gesture, if it is a valid hand gesture or facial expression, we have integrated an ultrasonic signal into the Google Meet plugin. So whenever a hearing impaired person or any individual gives a sign language, that ultrasonic signal automatically triggers the Google Meet backend and brings that screen in forward to this forward. So like any hearing impaired person is trying to speak, he can directly come at the front of the camera.
So as per your question, if you are a student who is hearing impaired, if you're using sign language, you can come in the front of the meet and you can really actively participate in the classroom activities with the teacher. This will not, so this is very inclusive for you as a student.
What about the scenario in which I have to hear out somebody from the screen, from the other end?
Yeah, so that is what our initial pipeline was. The mass communication pipeline, where the normal speaking human is converted into sign language. So think of you as a hearing impaired person who is at an airport or maybe at a railway station, right? So you are standing there, the announcement is being announced, and there would be a screen. Imagine a screen, and there would be a 3D character in the screen, and he will do the sign language. The backend is what we have made. The announcement, people won't have to do anything else rather than their regular speeches, and the sentences would be converted into sign. So you would be basically able to see that over the screen, the sign language by the 3D character, and then you will be able to interpret and understand what the announcement is.
Okay, that sounds really awesome. I mean, I think it's going to solve a huge problem there for a lot of people. So it's going to make their life very comfortable, very much more convenient to go around doing their daily chores. So from here, where do we go? In the sense that what is the next step in this particular direction?
Yeah, so we are in talks with our professor who was the POC for Smart and Hackathon from our institute, and we have to clarify if we can take some support from the government and do this internship in which we can make this model deployable to those specific domains that we talked earlier about. Our target is the mass communication and airports and railways. And if that is done, the later part would be for the education. These are the most important sectors that we have figured out throughout our hackathon. So
yeah, I mean that's correctly figured out. I mean these two sectors really need the actual push. But is there a plan behind this? Like how would you go to, or how will you take it to the masses, or a go-to-market strategy kind of a thing, or do you want to monetize it also at some stage?
Yes. So like as we have said, it is deployable. So right now we have to integrate more words. So initially there was 4,000 words in the IIT dictionary. we are like in the process of making those 4,000 even more, like more words we are going to integrate. So we are going to figure out key for the railway platforms what are the most common words which are being used. Like if like then we are targeting to go into the specific domains, other domains, and then figuring out what are the most common words over there, listing those, and having the broad dictionary which can eventually understand any word you are speaking, not like only focus to one domain itself, like in the daily life itself, peer-to-peer communications itself. So that's we are going to integrate. Another thing is like we are in talking with the professor, and maybe in the next months up to like governments, if they can help us, help us to deploy it, like we are perfectly ready to deploy it. It's just the government who can approve us and give us a chance to deploy it. That's
so
it.
we just need support and funds. The next steps would be, as you asked, would be to basically do some design thinking work over how much budget that government can allocate to this project, and therefore the cost of the screens should be, the cost of the hardware should be, and based on that we'll implement a small scale single output screen in their office where we are doing the internship. If and that would be working fine, which should be, because of our prototype is working fine. And based on that we'll scale, and based on economies of scale the cost should be lowered, and throughout the country this should be deployed. So that will take around 9 months for the eventual deploy that you can see in, you can see scaling in real time.
So it's really heartening to know that you are really ready for deployment and you're really ready to take it to the masses, and it's just a matter of time and the opportunity, a window of opportunity that you should be getting in a very short time. So I wish you all the best, and I hope that this sees light of the day sooner than later. And I'm sure this is going to benefit a huge number of people, and you are going to make a big mark in the this zone of innovation, and people will remember you for this contribution of yours. Thank you so much for joining us today and sharing your innovation with us. And we wish you all the best. And we look forward to seeing this particular innovation being used in the public spaces. Thank you so much.
Sure, we will do.
Definitely. Thank you so much for your time.
Thank you, sir.
A well-designed AI-powered tool like this, one could not only bridge the communication gaps, but also improve quality of life, accessibility, and independence for the speech and hearing impaired community. This team was really worthy of winning the SIH challenge. We will meet more such talented innovators in the editions to come. Stay tuned.